Hello guys, my name is Pavel Krupla from blenderfreak.com and I welcome you to the part number 26 of the Node Editor tutorial series. And in this part we are going to tackle the issue of having multiple edges connected to one single socket. So basically we do still want to have the behavior that input has only one single possible edge connected like this. But we do want to have the option to set up our socket, especially the output socket, to have multiple edges connected, because it makes sense that if we have one output, it can provide an input to several other nodes. So I hope you are excited and let's start coding. Okay, so basically when we want to use a socket, and when we want to assign more of the edges to the socket, we are unable anymore to use the node.edge equals to none, or assigning just a single variable of type edge here, as we are doing throughout the code. So this will be a great opportunity to refactor a little bit our code. So the first off, I'm gonna change this self.edge to be edges, and I will replace the none with an empty list itself. Let's add a new parameter here. So allow, or maybe just multi-edges, and by default that's gonna be true, I guess, for now. And we will create self.multi-edges, or better is multi-edges, and that's gonna be equal to multi-edges like this. And also we do wanna serialize this, so basically before the position we can set a new parameter here in the dictionary, and we can say multi-edges is gonna equal self.is multi-edges like this. And when we are creating the socket again, and that's I guess here in the node, if we are creating or deserialization, or we are doing the deserialization of the socket, we can by default keep whatever there was and use the socket deserialization to set the socket's ability to have multiple edges or not. Otherwise, the other option is just to pass the correct something like multi-edges equals to socket data something. I guess it was called multi-edges. We could type something like this, but in this case we wouldn't have the backwards compatibility with the format we actually created. I mean with the graph.json.txt. If you look at this, then we can find out any node here, and you can see we don't have this value here. So that's a major problem for us right now. So if I close this file and go up here, I guess I was here in the node. If I use this sentence or this here, this value doesn't need to exist in the file itself, and that would cause a problem. We could solve this with some versioning of the backwards compatibility, but in this case we haven't even released our software yet, so we don't need to take countermeasures for this, at least for now. We can just try to use the deserialize here, and we can assign, I guess we can do that here. So we can say self.is multi-edges is gonna equal to data self, not self but multi-edges, and this should assign to our socket if it's gonna be multi-edges or not. Anyways, this should to be enough, I guess, for now, for the socket. But for the edges here, we wanna do something a little bit different, because throughout the code, I guess we can check up if we have actually assigned the edge directly through the socket in the code. So if we look out for something like dot socket dot edge equals to, you see here is a bunch of code when we directly assigned an edge to some socket, and it's in the node edge, and that's a huge mistake we made, because now when we choose to change the logic, for example here, set connected edge, we are not calling it through this method. So that's another problem for us. So let's have a look at the node edge itself, which is currently here, and let's fix this one first. So I guess it was dot set connected edge. So set connected edge, and that's gonna be self here, and here is gonna be the same thing. So set connected edge is gonna be self. And I guess we were using none also in line 83, which is here, remove from sockets. So we can call set connected edge is equal to none, which doesn't make any sense for us now because we are using a list. We should be calling something like remove connected edge. So in this case, I'm going to write a command here to fix me, because there is an awesome feature here in the PyCharm. Here is a to-do list, and as you can see here we got a list of to-dos we need to do because we just wrote this command here. So do not forget about this one. I'm just going to rename this also, and I will write a command here because we are supposed to not assigning we shouldn't be assigning none to a list because it doesn't make any sense. But anyways, the set connected edge itself is awkward name here right now, so we can basically rename that to something like add edge and do the whole refactoring thing. And in our case, the edge is not gonna be none anymore. We shouldn't be calling add edge without specifying an edge we are trying to add to this self.edges list inside of our socket. So basically we need to also change this line to append to a list, and we are going to append the edge. And also I guess we won't be using has edge anymore, but probably when we are appending to the list we are going to remove the edges from the list also. So let's try to write a new function called remove edge, and that's gonna be self and edge, usual stuff. And here I do wanna have a check if actually the edge is being appended to the list itself. And the reason why is pretty simple, because here is an example. When I have an empty list and I'm trying to remove something which is not in the list, I will get value error exception, and I do not wanna handle with the exceptions when I'm removing here, but also I do wanna be notified somehow that something is broken, because this shouldn't be happening when I'm trying to remove an edge anyways. So I will do a check, so I will ask if edge is basically in the list, so self.edges, and if it is, I can just safely remove that from the list. So self.edges.remove edge. But if it's not in the list, I do want to see some kind of a warning. So for now I will choose something like exclamation mark W. That's gonna be, this is class socket, I guess. So socket remove edge. So we can say wanna remove edge, and we can write out the edge which we are trying to remove from self.edges, but it's not in the list. And I will copy these two lines because I guess we got something similar also somewhere else. So basically this should be our remove edge, and I guess in the scene, yes, in the scene we are adding node and adding edges, and that's a list also, so we can use the same check here just to be sure that our code is basically working properly as it should be. Otherwise we will be notified. So now we are checking if node is in self.nodes. Otherwise this is scene remove node. Wanna remove node, but it's not in the self nodes. And here is edges, remove edge, and the naming here is the same, so we can keep this line, but I will change the class name here, so the scene remove edge. Okay, so this should be okay. I will still not try to run the code because it's gonna be broken yet. So in the node socket, basically what we are doing, all of the callings which were not using this method should be away already. Let's check out the to-do if it actually renamed the calling. Yes, it has. So this is awesome. So now when I'm removing from the sockets, this should be remove edge, definitely. Okay, but as you can see, we are basically in the edge unsetting the socket itself, setting it to none, and still we need to think that we should reset or remove the link inside of the socket itself. So there could be a clever way how to do that, I guess. And if we have a look here, when we're creating an edge and we know the start socket and end socket itself, we are basically calling this setter here, which goes to the socket itself and adds the edge here. So let's write a few commands here, and I will start with this first line. That's gonna be assign new start socket, and in the end it's gonna be the same, but it's gonna be the new end socket like this. And when we are set up, we are calling add edge to the socket class. And I can copy this comment here also to make it a little bit cleaner, but we can check if there was some previous value in the socket. We can just remove the edge from the previous socket, if it does make sense, because when we have an edge connected somewhere and we connect it to somewhere else, we do want to remove that from the socket. So basically, if we were assigned to some socket before, delete us from the socket. and I guess the same logic is gonna happen here also. So we'll copy this command here, and we can check if self._start_socket is not none. So the so-called start socket protected kind of ish variable, because in Python there are no protected variables, so we use this notation with the underscore to suggest to the reader that that's something he shouldn't be changing from the outside. So basically, if it was not none, then we wanna go to the start socket and remove the edge ourselves from the start socket where we were. And basically the same thing will go to the end socket also. So if underscore end socket is not none, then we are going to remove ourselves from the end socket. But right now, if I run the code, I should get an error. Exactly. Here it is, attribute error. Edge object has no attribute, because we are actually checking here in the start socket what's this variable's value, and we are doing that from the constructor here, and we haven't ever set this variable before. So that's an easy fix. This is gonna be the default initialization, and we will say that self_end socket is gonna be none, and the self._start socket is gonna be none also. So this should be our edge, I guess. Pretty much done. This we need to fix later. Remove edge, start socket, end socket. And basically that means that if we are now setting the start socket that is gonna be none, we are basically removing ourselves also. So in this case, this whole bunch of code is not necessary anymore. So therefore it makes us a little bit cleaner code, and we don't need to think anymore what's gonna happen if we change the start socket, what's gonna happen with the sockets. So basically this should be the edge itself. Let's try to run the application and have a look what's going on. I just click and start moving, and the application crashed. So that means we do need to go in the node graphic view, I guess, where we handle the mouse press event, release event, and I guess the mouse move event also. So let's have a look here. Here is a right mouse button press, and I guess we broke a whole bunch of things. So let's check out the right mouse button. As you can see here, clicking here in the empty space for the scene, the right mouse button click works. If I click on the node, it just crashed again. So let's have a look here when we are here, and we are basically checking the right mouse button press, get item at click, and if the type is QDM graphic socket, then we are printing out the item socket and has edge, and the socket has not this parameter anymore, it has only edges, which is the list we just created, so has edges. Let's try it again. We'll right click on the socket, and here we go. Here is an edge object at something blah blah blah. Okay, so this should be working, and the graphic edge should be working also. So let's try that. Yeah, here you can see our edge right mouse button click is working. So let's have a look a little bit further. and here is our mouse move event. Here is self drag edge, which I don't like too much, but anyways, we will go ahead for now. And here is edge drag start and edge drag end, and I don't like this bunch of code also. So let's do some cleanup here. In the first place, we should probably not be using the drag edge here and reassigning a whole bunch of socket logic, because it's not readable at all, and even it's without any command here. So basically it takes me a little bit longer time to realize what's actually happening here. So if we edge drag end here, we check if the item we clicked is a graphical socket and it's not the last start socket, which is supposed to be the socket when we start dragging. So that means I can write a command here that if we released dragging on a socket under, then the beginning socket, then we are running this whole bunch of code. But there should be, you could basically write this a little bit simpler, I guess. In the first place, I do want to always see that we are actually in this function here. So I will move this one first, and then I can just, what we are doing here in the drag start, let me close this for a moment. When we click, we are assigning previous edges, which is item socket edge, which doesn't exist anymore. So I will comment this out because this doesn't make any sense. And therefore we are storing last start socket, and we are also creating a new edge, which is our dragging edge. So first off, I see this inconsistency of the naming here, so I will rename drag edge to drag underscore edge with a lowercase, so it's consistent with the naming here. And this last start socket is really confusing, so I will rename that to be drag start socket. So drag edge, drag start socket. Now it makes sense what's gonna do, or why we're using these variables here. And then we can move to the edge drag end. So basically at the beginning, always when we end it with the dragging, we can remove or delete the dragging edge itself, because we already have stored position where we started, or the socket where we started with the dragging. And here, when we check for the item.socket, if it's actually something else than where we started the dragging, we got the target. So basically almost all of this code could be replaced with just creating a new edge, because we know from the edge is coming and to where is the edge coming. So basically previous edge here doesn't make sense anymore, but I do want to keep everything done statement here at the end, so I can easily see if the function works or crashes or something. So basically we are removing the edge, then the previous edge we don't care. We remove the hasEdge function because we don't need it anymore, and we are trying to remove edges, so this is basically wrong. And we can replace this code with something like for edge in item.socket.edges, and we can say edge.remove, and this should be working now. Assign end socket. doesn't make sense. Previous edge deleted, previous edge removed, doesn't make sense. Reassigning the sockets doesn't make sense anymore, and drag edge update position, we don't need that anymore because we already deleted the edge itself. So instead of that, we can just create a new edge, and that's gonna be edge, and first we are assigning scene, start socket and end socket, and edge type. So self graphical scene.scene is gonna equal self dot drag start socket, and we will end up in our target. That's gonna be item.socket, and the edge type is gonna be edge type Bezier, and we can write if debug. We can print that something happened, that we created an edge actually. So I will copy this character here, and I will say created new edge, and we were connecting new underscore edge dot start socket to new edge underscore or dot end socket, like this, and this should be cool. So let's try that out. If I try to move, it crashed. Let's try again. If I start dragging and release the mouse somewhere in the space, and dragging edge, everything done, and our console has assigned start socket to created and drag edge, and dragging edge, and everything done, and we are still up and running, so that's cool. And here we created a new edge, and I started to drag with the node, and we got crash. But probably, as you can see here, we created a new edge connecting socket and everything. So probably we went through all of this function we just written here. So let's have a look on the movement of the node. And here, when we are calling node update connected edges, we are asking if it has edge, and it does not have this method anymore. So therefore we are going to say for edge in socket dot edges edge dot update position, and immediately we can see even here below in the remove function that there is something wrong here also. So if we remove the node itself, removing node, okay, go through all of this socket, we don't have this method anymore, and we are trying to call edges.remove. So basically that's the same thing. We can say for edge in socket.edges, and here is the socket, and here are the edges. We can say edges.remove or edge.remove, and here we will write out this edge only like this. Then we are removing the graphical node, debug, remove node, okay, that should be done. Here is our famous deserialization, which should be working, I guess, for the new socket. Okay, is multi-edges, now this one works. So let's have a look, and here we go, and we are successfully moving with our nodes, which is awesome. And I can drag the edges, that's working, we are not crashing, and I can drag another edge, and now we got two edges connected into this one socket here. And if we right click, you can see this is a list already having two edges, so this one is correct. And now we just delete this one. Write down we got edge 7F0 and 890. If I try to do this one, we ended dragging edge and we lost one connection here. So what happened? We got only two edges and we created a new edge, 8940. Okay, so we will need to investigate this one, and if I close this one, I will disable this ugly dialog here. Just quickly set modified. Serve.scene has been modified. Okay, that should be in our scene. Has been modified is returning this variable, but we will force to return false for now. So let's try that. I will move something, close, and no ugly sound with the dialog. So I wanted to know what's happening with the code. So let's delete this one. Let's delete this node. Let's have a look. Now we got two nodes, one edge. I will create second edge. This is working. We got 7B8, which is here. 7B8 and D6-8. Here is one edge, another edge, and here should be the last edge. So let's try to drag an edge from here up to here, and one of our edges disappeared. So basically we don't need this editor anymore, and let's have a look what actually happened, if we can realize what's going on actually. So start dragging edge, assigning start socket to 710, which is correct. 710, it hadn't any edge before, and we are creating CF8. We ended the dragging edge and we created a new edge. So somewhere between end dragging edge and creating the new edge, we lost our edge from here. Okay, that means the problem should be somewhere here. If the item socket is not the same thing as it was, then we are asking these item socket edges to remove all the edges we connected there. And this is probably deleting our edges here. So if debug, let's check it out. If debug, print view edge drag and clean up edges in target, or maybe just lowercase, clean up edges in target, and here we are going to output our edge. So that's this edge, and then we will write removed. Start it again. Okay. And it's like this. Two nodes. I will drag it back, and this one was deleted. It shouldn't be, and our dragging edge is 5F8, but clean up edges in target. We found this one, F98, and this one, 550. That means here should be 550 and our new dragging edge 5F8. Okay, this one is here. But why was this one removed and not the other one also? So I think I figured that out already. So basically, when we are deleting items from the list itself, we are messing up with the list iterator which is inside of our for loop here. So instead of this, I will just call a new function. So item.socket.edges, no, not .edges, but we will call remove all edges like this, and we will create this new function here in our socket which will handle the deleting of or removing all of the edges in the list for us. So basically, new function in the socket, define remove all edges, self, and here we need to use while loop. So we can type something like while self.edges, and this will check if the self edges is empty or not. We can get the edge. So the edge is gonna be a.pop, the first element, and with a I mean the list. So self edges pop 0. And is there something special we want to do with the edge? I guess we are not. So this should remove all of the edges here, or we can just call something like self.edges.clear like this. So it depends on what you want to do. If you need to do something with the edges, you can use this line, and you can return something or call whatever function on the popped element here. So back to our code here, we will use remove all edges. Now when I press play, and I will assign it like this and go here, and you can see these two edges were detached from the socket, so now it properly works, but still we need to somehow delete these two edges here. So anyways, we need to call edge.remove on each of the elements here. Remove all edges in our case is not sufficient to call self edge clear, but we need to use this one and say edge equals to self edges pop, and we can call edge.remove. Okay, going back here, press play. I will have two edges here, they are still connected. When I go this way, all of the edges disappeared because they were deleted, and now when with the right click we should see two edges only because we got two edges here. Let's check out this socket. This got one edge, this should be empty, right here should be an edge, and this should be empty. So now it basically works, but we lost our connection to the elements or the edges before, because basically the socket can be one of two types. It can have multiple edges or it cannot. So basically we need to check if the item.socket is multiple edges, then we are doing nothing because we wanna keep all the edges coming from target socket But otherwise, if it's not a multi-edge socket, then we wanna remove all the edges like this. So let's test that out. And I'm not sure if I actually set this socket to be multi-edges. Yes, I did, so now it works. But what's gonna happen if we try to drag something here? Now we got two connections in the input, and we don't wanna have multiple connections in one input. So basically, somewhere here, yeah, here it is. In the node editor widget, we are creating nodes and edges, which is our default, and we do want to go to the inputs and outputs, and we want to say that our input by default will not be able to have multiple connections, so multi-edges is gonna be false, and the default for our outputs is gonna be multi-edges true. So let's test it out, and here we go. Okay, multiple outputs, we got two edges coming out, and when I do this, it's still working and it's still connected. That's also, but when I drag some other input or output to the input, I will lose the connection here, because there is supposed to be only one. And to distinguish a little bit more if the socket itself is multi-edged or single-edged, I will go ahead to the socket, node socket here, and we got somewhere here, here's our string, and I will write new information here, and we will write out something like multi-edges if self dot is multi-edges, otherwise we will write single edge or SA, like single edged. Let's test it out, and when I right click here on this socket, we can see that's multi-edge and single edge and single edge. Nice. So let's try something like this. Let's test out our saving mechanism. This one works, and let's reconnect the socket here and created a new edge, and we crashed for some reason. Let's try it again. Now we didn't crash. It's really silly. And this one should be multi-edge, single edge, single edge, single edge. Let's try to save this. Graph 2. Save. And let's have a look how our file looks like. Multi-edge is false, false, false. And in the output multi-edge is true, false, 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 and in the output it's true. And we got saved 1, 2, 3 edges, which is correct. So now I clean that up and open again the graph2.json. It's successfully loaded up. But still, I would like to figure out why it crashed before. So maybe someday later we will figure that out. So as the last thing, I noticed bug. When I start dragging from the input to the output, you can see this is correct, but this old edge here have not disappeared. And the reason why is because I messed up here with the code, because when I drag end it and checking out if I should remove the edges. I'm just checking for the target socket and not for the source socket itself. So less code means less bugs, so I will write it a little bit different here, and I will negate this condition to use just 2 lines, and I do want to copy that and do the same thing for the source. For start socket, and start socket is self dot drag start socket, and now we should be good. So open graph.json, here we go, drag it here, alt edge removed, nice. We got only 3 edges here, and let's try to reconnect that, and it works. So let's have a quick look, Ctrl C, Ctrl V, and this is still working. Let's try to connect these. Yeah, nice. So now I can call this part finished, and thank you for watching, and see you at the next part.